Let us look into the fit principle from the solid, which is the last one, dependency inversion principle. And this DIP, or the dependency inversion principle, states that the high level module should not depend on the low level modules, but both of them should depend on the abstraction. So when you read this, you can notice here that it says that the high level module should not depend on the low level module, which means that it should not depend directly on the low level module, but it should depend on the abstraction. So here we are trying to decouple the high level module and the low level module, so they are not tightly coupled, which will give us the like reusability. So when we change certain things in our low level module, that should not affect our high level module. So the high level module can be reusable, and it doesn't get affected by the changes on our lower level module. So in this way we can achieve the abstraction. So we can abstract it and decouple, and we can decouple the high level module and the low level module from each other. So the main point is of the decoupling over here. So we should not tightly couple the high level module and the low level module. Based on this, the Robert C. Martin, which is the Uncle Bob, as you all know, has a definition of the dependency inversion principle into two parts, which says that the high level module should not depend on the low level module, but both of them should depend on the abstraction. So abstraction, we should depend on the abstraction, but not on the concrete implementation. Abstraction should depend on the detail, and the detail should not depend on the abstraction. So abstraction should not depend on the detail. So your abstraction should not depend on the detail, and the detail should not depend on the abstraction. When you read this, you get quite confused what actually it is, but when you implement that practically, you will have much more clear understanding about it. So let's leave this definition over here, and just remember that what it actually says is the high level module should not depend on the low level module, but both of them should depend on the abstraction. So that is the key point to remember over here. So let us move into the project that we are building. So let's go back over there. Here I have created a folder DIP, and then dependency inversion principle, and I have a problem and the solution folder. So inside this problem, let us create a new file, and I'll create a main.the file, and I'll have a main function over here. And let's create a new file over here. Let's call it as let's say SQLite service.the file. Maybe we have SQLite service, and then we will have one more, which is, let's say user repository .the file. And then we may also have one more class, let's say new, and let's say a user.the file. And in this class, let's go and create a class of the, let's say, SQLite service. And also let's go and create some function over here. Let's say a void, and let's say connect. So let's say we want to connect to the SQLite, and I just want to print something here like the SQLite connected, right? We want to connect over that, and let's say you want to have some other functionality of, let's say void insert or something like that. So you can just print out something from here, and let's call it as inserted. Okay, so we have a connect and the insert function over here, and let's go to the repository, and let's create a class, and let's call this one as we have a user repository, and then I will have a final, and let's depend on the SQLite service over here. So I'll just say SQLite service, and I'll just call it as a SQLite service, or I will just call it as a service for now. And let's create a constructor for this one, and let's create a constructor, and here I will have a new function. So let's say a void, and then what we will do is, let's say insert, right? So we can insert something from here, and let's say I will just pass in the service that we have, service class dot the insert. We'll just call that insert, and then we will have one more function, that is we have a void to connect, right? And then we can, I think I will just leave it as connect for now, that's not required. So let's have just an insert functionality in our repository service class. This is I'm trying to explain it in the real world example, so how we can actually use a dependency injection and the dependency inversion of control. So let's create a class, and we will have a user, and this user, let's have a final variable of the user repository that we have created. This will depend on the user repository, and then let's have the constructor for that one. So final constructor. Now I can just go and let's say a void and insert the user. So we want to call insert user, and now I can insert the user, and here we will call that as a repository that we have. So user repository dot I can insert it. So we have a few classes over here. One is of SQLite, which has a connect functionality and insert. And in the user repository, we have this, it takes the service, SQLite service, and then we have a functionality to insert. And then in the user, we have this particular class. Now let's go back to the main. Now I need to have access to the final user, and this user is our user class that we have. And now this requires a user repository dependency. So for that, I will have a final and the user repository that we have. So user repository, which is of equals to the user repository over here. So this one will require a service again, so which is of SQLite service. So final, and then we have the user, it should be of the SQLite service that we have, and this is of the service that we want to create. So SQLite service that we have. Now I can finally go and call the user dot the insert, right? So I just want to go and call the insert functionality, and then I can just go and run this one, and this works perfectly fine, which we can see as inserted. Also we can just call the service dot the connect from here. So now if I can run this, you can see SQLite connected and the inserted. So this is, you can see you don't see any issue over here, right? As a normal user, you will not notice anything unusual over here. It's working perfectly fine. So we have a user, and that depends on the user repository, and the user repository depends on the service class, and then the SQLite, we have this the service class. Now next time, let's say you want to replace this particular SQLite service with the, let's say, a Hive or maybe a MySQL service. So let's say next time you want to have a new database service class, and let's say MySQL service dot, and then I will just copy the same functionality from here, and then I have to, now what we have to do is this user repository, I have to go and change this one from here to something MySQL, right? So MySQL, so what was that? Sorry, okay, so I forgot to create a class. So class MySQL service, and here we will have that functionality to connect and the print. So should be MySQL connected. And now here I need to change that one to the MySQL service, and then I again have to go to this main, and again here whenever you are creating the user repository, you have to pass that service. So here you have to create the final and then MySQL service, which is of service and which is of equals to MySQL service. So here you can see you have to change in the lot of stuff, and as we saw in the definition from the dependency inversion principle, it says that the higher level module, right? So which is this is the higher level module, also this is the higher level module, so depend on the abstraction. So your higher level module or the lower level, which this is our lower level module currently, it should depend on the abstraction but not on the concrete implementation. Here we are actually using a concrete class instead of the abstraction. So this is not abstract class or the interface, but this is a concrete class. So here we are implementing it directly. So we get the issue when we want to replace something. So it also mentioned that when you make a changes to your lower level module, that should not affect your higher level module. So this class should be reusable. So this is the main thing about the dependency inversion principle. You may be a bit confused about the dependency inversion and the dependency injection. So dependency injection is what we are doing over here. So if you see in this particular class, we are dependent on the MySQL service class, and when we are creating that particular repository class, we are providing the dependency over here as injected as a constructor. So in the constructor we are injecting the dependency. So this is a dependency injection, but this is not a dependency inversion control principle. Both of them work together, so but they are differently. Okay, so dependency injection is a different thing and a dependency inversion principle is a different thing. So let us find the solution for this one. What I will do is I'll go, and I guess I can just copy this main function. So just paste it over here and just leave it at for now, and then we will also copy some of I guess I'll copy, first of all I'll create a new file and call it as let's say the database underscore service class. Here I see the dot file, and I'll create a class, and let's call it as a database service, right? And let's make this one as a abstract class. And what I will do is I will have a functionality of this over here. Just copy this one and just paste it over here. So let's not do the implementation over here. So implemented should be done in the implemented class. So whichever class is implementing this database, it should implement that to functionality. So we have a database service now over here. And then what we will do is we will create a new class and call it as a SQLite, or we see SQLite service.the file, and let's create a class of the SQLite service, and that will extend from our database service, right? So we will extend it from our database service, and here we will implement that to missing functionality. So here we will just have that print, right? And let's say SQLite connected, and then that should be fine. Okay, so I guess spelling CONN is it connected, and here we will just print out something like inserted. That should be fine. So we have SQLite service, and then I will have a new file of the, let's see, user repository dot. And let's copy the functionality from here. Just copy this and go to user repository and just paste it over here. So now we don't want to depend on the concrete class, we want to depend on the abstraction. So what we have to do is I have to remove this and call the database service over here. And then I can just go to the create a new again file, and it should be of a user.dot file. And in the user.dot file, I'll just copy the whole functionality and just paste it over here. And here I will just import the user repository. That should be fine. And in the main, what we need to do now is just remove all of this. And here I need a service class, right? So this user repository requires a database service, so I just have to create a database service, and it should be of the database service over here. Okay, so it is not a database service. Now we require a SQLite over here, right? This is an abstract class, so we cannot use it. So let me just remove this one, and then we will just uncomment this one. So let's have this one, and this one we can just remove this one too, and this one we will just import it. So now you can see that it is working fine. And now if I want to add a new service later, let's say MySQL underscore serv service.dot, and let me extend it, and let me copy this functionality. So let's go to the MySQL and let's create a class of the MySQL. So class and class class and the MySQL service, and then paste that one, and then just import this particular functionality. So just import the database service. Okay, so this should be of the MySQL. So now even if I want to change from here, so let's say if I have in the user repository, I don't have to go and change, since this is a higher level module from the service. The MySQL and the SQLite service are lower level service, and then my user repository is a higher level module. Okay, so here what we are doing is we are dependent on the abstraction, so we are not depending on the concrete class over here. And then what we can do is if I go to the let's go to something like in the main, and now when I want to change to a different, like the MySQL over here, so let's say MySQL service, and that service is coming from the another, I guess. So I need to remove this one, wrong import. If you have the same name, that's the issue. So now I just have to change the MySQL, and it can accept that one. You don't have to change any of the functionality inside the user repository as well, because this depends on the abstraction over here. Similarly, you can also have an abstraction for the user repository, and then you can just create a new file, and you can have a user repository, or user repository dot, and so we have, I guess, a spelling mistake. So it should be of a user repository, and I will make it as a IMP implementation. So let's create a class of the user repository implementation that will extend from the user repository class. Okay, so we have extend in the user repository. I don't want to have all of this, right? So I'll just extract. I will just I don't need to have this over here, so I will create this one as a abstract class. So abstract class, and then I don't want to have this, I'll just have the functionality function to insert. So now we have an abstract class which is our user repository, and we have a implementation over here. So I'll just go and create a, let me pass it over here for this one, database service, and I need to have it over here, and I need to import this one. So let's import the database service and implicitly evoke why it is the user repository. I can just remove that, and this one should from our user repository, and here I need to fix that particular issue. So missing override. Okay, so now here what we did is we are now dependent on the abstraction, but not on the concrete implementation. So even this particular higher level module, which is the user repository, now depend on the abstraction from the user repository of the abstract class that we have created over here. And if I go over here, I need to make use of the IMPL, not that one. And this way, if I go to user, now this user should not depend on the direct implementation of the user repository. Now it is dependent on the abstract class. So this is the abstract class, not the direct implementation, right? Not a concrete class. So now even if I have another class passing over here, let's say I have a new file and profile, let's say profile, and then profile repository dot the dart file, repository repository dot the dart file. So class and the profile repository, so repository repository, and then this profile repository, let's say implementation, let's call this one as implementation, and that extends from the let's say user repository that we have, and let's go that one, and let me have that implementation over here. So override that, right? And same thing, so I can just depend on the final class of the database service, and I can just call it as a service, and let's have the constructor for this one too. So now we have this, and if I go to this particular user, we have a user repository. This is abstract class, and also if you go to the profile, where is that profile repository? I'll just rename this one to the implementation, so I don't get IMPL implementation. Now this also this depends on the database service. This is also extending from the user repository. So if I go and go to my main over here, instead of this user repository is dependent on the my service, and now user depends on this user repository. But if I just rename as a common name as repository repository, and just pass in as over here, and instead of the user repository, I can just pass in like a profile repository implementation over here. So in this way I can make use of the reusability, right? Also when my profile is extending from the user repository, and then my the user repository is implementing from this one, I can when the certain change happen on the lower level, your higher level module doesn't get affected. Similarly, like here in the MySQL service, we are extending from the abstract class, which is for database service. Similarly, the SQLite is also extending from the database service. So we are not hardly coupled, we are not tightly coupled. So these classes are not tightly coupled, which has a decoupling, and it depends on the abstraction. That's why we can easily switch the things. Like if you want to test or pass a fake, or you want to pass a mock object over here for testing, that can be easily done over here. So that is the main concept. So I hope you got some idea about it, and try to learn more about it, try to implement more about it. Solid principles are really important, and if you want to be a better programmer, you have to have idea about the solid knowledge. So make sure you practice all of this, not just by watching the video, but by implementing yourself. So try to understand, and we'll meet up in the next lecture. Till then, have a great day.